All right, so in this video we are going to do a practice exercise. We're going to work through some challenges. Okay, so I'm going to work on this checkpoint cars. It is in your course material, checkpoint after loops folder, and this one that says cars ID is 222. The exercise ID is 222. So what I'm going to do is I'm going to just copy the file, and I'm going to paste it in the same folder, which creates a copy, and I'm going to rename it. And instead of calling it copy, I'm just going to call it solution. So you will find this in your course material. So what is this doing? We have 9 challenges, 9 exercises based on this data type or this data structure. It's a data structure of cars. It looks like it's a list. We can see that it is a list of dictionaries. It's a list that contains multiple dictionaries, and each dictionary is information about a car. So based on this, we have practice exercises, 9 of them, and this comes right after the loop section. So you have to know if-else statements and loops, while loops, for loops, mainly for loops for this exercise. So this is a checkpoint. Try to solve this exercise and then watch the video. Okay, and the solution also, you have it available. All right, so let's start with exercise number 1. It says print the make and model of each car. So as soon as you see the word each, you got to start thinking about a loop, specifically a for loop, because when it says each, you have something that you can iterate through, and you got to go look at each one. So always, whenever you see the word each, always think about a loop. So basically what it's saying is to go through each one of those and print out the make and the model. So we know it's a dictionary, so we can just access the make and the model. So let's start with our for loop for I in cars. Right, in cars, let's just print I. It's always good to do it one step at a time. Maybe this is too basic, but when you're new, you always want to just go do one step, test it out, run it, and do another step, test it out, and keep going like that. So we just run this right now. So it's going to go through each one and print each dictionary. But what we need is, we actually want the make and the model. So each item is a dictionary, so we can get a make and a model. So we're gonna do make, and we're gonna duplicate that. I did command D to duplicate, or control D, and model. So now if we run that, it will run it this way, right? That's all it's asking us for, but sometimes you want to take it a step further and make it nicer. Just format it in a way that you think will be more acceptable. So for example, to differentiate between each car, I'm just going to print a line. So when I run it now, so it looks a little bit better, right? Every car, there's a line. Another thing is I can actually print out the make and model. So I can say make is that. Okay, close the brace, double quotes, duplicate that, do model here, and delete this part. Okay, now if I run it, it's a little bit nice. It actually says make model. It says make here. Let me do model. So if I run that again, there you go. Okay, that is basically the solution for exercise number 1. So we're going to look at number 2. So for number 2, it is saying calculate the average mileage of the available cars. So we got to look at a car that is available and calculate an average. So calculate the average mileage. So we have to know how to calculate averages, and we're going to calculate the average mileage of available cars. It's not all cars, only cars that are available. So how do you calculate average? So we look at, let's take some notes. So average is going to be total amount, right? Total amount divided by number of elements. That's the average, right? So we got to identify cars that are available, because when you look at the data structure for each car, there is a field called is available, and it's set to true or false. So for example, this guy is a Honda Accord. It's not available, it's false, so we're not going to add it into our calculation, because it is asking specifically for available cars. So first, let's write the code that will identify only the available cars. So we're going to say, first we're going to say for I in cars, okay? I'm going to check if I, what is the field, is available. So we're going to do is available a lot of times when you're a beginner, you'll say if I is true, but you don't really have to do that. I'm going to leave it as a comment, but if you just leave it like that, if you just say if I should have done the other way around. Let me do this, because the right way to do it, they're both right, but the Pythonic way to do it is just like this. So I'm going to comment this out just to leave it there. But you can do this. You can just check if something is true or not without actually comparing it. This will return true if it's true, or if it has any value. This will be false if it's actually false, or it's an empty string or an empty list or a none. All of this will evaluate to false. So you can just do this. So if this is true, then we're going to say print I, just to check it out. So now we can see it's just going to print the available cars. So it printed the Toyota Camry, the Ford Mustang, and the Chevy Camaro, right? So we look at it. It printed Camry because it's true. That's all right. It did not print Accord. Perfect. It printed Ford because it's true. It printed the Camaro because it's true. It never printed the Nissan. So we know our logic here is correct. It's only printing when it's true or not. Now what we need to do is, how do we figure out how many total cars are available and what is the total amount, right? So there's a lot of ways you can approach it. The way I want to do it is I want to actually set variables. I can say total mileage and set it to 0. You have to initiate it from 0. Then we say number of cars, again with 0. So every time we find an available car, we're going to add 1 to number of cars. So we're going to say number of cars, oops, let me copy that. We're going to say number of cars is equal to whatever the number of cars used to be plus 1, right? We take the value of the current value of number of cars, add 1 more to it, and set it again to the new value. So that way, every time we find another car that's available, we keep just adding the number. But there is a better way to do as a programmer. There's a simpler way to write this. We write it like that. These two lines, they mean the same thing. So I'm just going to comment it out. I'm going to leave it there so you can use it as a note. So I'm going to say this does same thing as the next line. I can actually put that comment in this one as well. Command C, Command V. So now it's going to print out number of cars, right? So we can actually say print number of cars just to play with it, just to experiment. We run it. You can see every time it finds a car, it's going to print 1, 2, and 3. It's printing this. So the problem with this exercise is when we run all this, it's going to execute all of that. Okay, so I'm going to disable this. I mean this part. So whenever we try and run, we just want to see the output of exercise 2. So we're going to make sure this doesn't get printed. The way I do that is I just said I can comment it out. I can comment the whole thing out. I don't know why my keyboard is doing that to me right now. I can comment the whole thing out, but instead of doing that, so you won't get confused later on, I'm just going to say if false, because I'm just hard coding false. So if false will never execute because this is always false, right? I'm just setting it to false, hard coding it. So this way, when I run it, it won't run that part. It will only run this part here. So I'm going to leave that as is, so you understand why I'm doing if false. You can just get rid of it later on. Hopefully that makes sense. Hopefully that's better than commenting it out, so you don't get confused with the actual code that's supposed to run versus the actual comment. So this is better. I'll add a note on top of it to explain. That's what I'm doing here. Okay, so now we can see it is actually printing number of cars. Now we also want to keep track of the mileage, right? So for this car here, the mileage is going to be I, and what's the key? Mileage. So we're going to do I mileage. So we're going to take the total mileage. We're going to say total mileage is equal to the same thing, the current total mileage plus mileage, right? And we can even say current car mileage, because this is just to make it a little bit more clear. Again, instead of doing that, you can totally do this. This is a shortcut. This is how you normally write it, so I'm going to comment it out. Okay, so if I print total mileage and execute. You can see the mileage is going up every time it prints. It was 45, then 70,000 and 75,000 every time it gets added. Okay, so now average is going to be total mileage divided total number of cars. What is it? Number of cars, right? Not total number of cars. Print the average mileage of available cars is. So we're going to use the F string here and we're going to print out average. Okay, and when we run it, we're going to get that. Let's clean it out. We don't need to print this part here. We don't need to print this part here because so the output can be clean. Then it says the average mileage of available cars is 2,500. I don't know why it's still printing this guy here. Let's see, can I clear this and then run it? There you go. Okay, it just printed that. So we just did number 2. Now we're going to disable this. We're going to take this, we're going to put if false. I'm going to do if false and put everything underneath that. So when we run it, it won't print anything. It won't run anything. It's not running anything because everything is false. And then we're going to move on and work on exercise number 3. All right, exercise number 3. So now this one is asking us to find the most expensive car. So out of each of these cars, we're going to find which car is the most expensive car. Okay, so we're going to set a variable in this case. So we're going to loop through each car, like for I in cars, and we're going to do something with that. So the price of the car is basically price, right? And it's already an integer, so we don't have to convert it. So we're going to say car price is I price. Okay, so now the question is, how do we know which one is the maximum? So we can say max car, or like we can say expensive car. We're going to set it to none. We're going to start with none. Okay, so we're going to say if expensive car, is basically not set, or we can say if not expensive car, basically saying this is saying the same as, I'm going to do the same thing I did earlier, if expensive car is equal to none. Okay, then we're going to say expensive car is the current car, which is I, right? Because when we first start, let's just think about, we're not even doing this. Let's just think about this for a second. On the first loop, when the first time the loop runs, the first car we find, we didn't figure out any car at all. So we're just going to set the first car we find as the most expensive. Then we're going to keep checking the rest of them. If there is anything more expensive, then we're going to add it as the expensive car. We're going to use that one as the expensive car. So the first time we're going to run, basically, if expensive car is none, just take the first one we found, the current one, and set that to be as an expensive, right? Then we can say else we're going to say if the current car, right? If I price is greater than the expensive car price, then now we're going to say expensive car to be the new one, right? Every time we're looping through. So the reason I have this here, I will explain this. The reason I have this here is, instead of doing this, you can always do that. Okay, if not expensive car, basically if not false, which is true, yeah, if the expensive car is not set, if expensive car is not set, you can use that sentence. This is called truthiness. You can look up truthiness. It's the same concept I showed here. You don't have to compare it if it's true or not. The same thing. You don't have to compare it with a none value or not. In fact, I think I want to keep the proper way. Leave this there and leave that there. Actually use it. So this one is a little tricky. Eventually, this type of thing you're going to do it very, very often. So it's going to be very familiar. But this is how you do it. So you set it to the expensive car to none. The first time you run, you see if it's none. If it's none, just take that car and set it as the expensive car. But the next time you run, this is not none, so it's going to go here. So we're going to look at the current car, and we're going to compare the price of the current car with the most expensive, with the expensive car from the previous step. So if the current car's price is more than the previous car's price, then you're going to make the current car to be the most expensive one. And you keep going. On the next one, you compare it from the previous one. If the next one is happening to be more expensive, you're going to set that to be the most expensive. If not, you just leave it alone. So literally, that's what this is doing. And so at the end, you're going to say, we're going to do print the most expensive car is. Okay. Do you want to print the whole thing, the whole dictionary? Because expensive car is a dictionary. Again, you're going to print it every step for you to look at it. But we're just going to print the make and model. So I'm going to say the most expensive car is, I'm going to say expensive car, make, and comma, expensive car, model. Actually, the comma would have to go outside. It would have to be like this. So hopefully this makes sense. You gotta go a little slow and look at it. So if we run the script, the most expensive car is Chevrolet Camaro. So let's look at it. Let's see, since this is a small list, we can actually visually check it out. The Nissan is 12,000. The Camaro is 30,000. The Ford is 25,000. This one is 18,000 and this one is 15,000. So yeah, the Camaro is 30,000. It is the most expensive. So we know our code actually works. So this one is a little tricky initially because if you've never done any logic like this, but just take it slow and try to go through this, try to understand it, and it would make a lot of sense. All right. So that is number 3. Let's disable it. If false, take everything and put it under false. If you want to run the specific test, all you have to, the specific script or snippet, all you have to do is change this to true. So now if I run it, it won't run anything, right? It just printed the file names. If I do clear, I don't like how it does this. If I run it, nothing is printed, it's just a file name. So here I can just change it to true. So this part can actually get executed. Hopefully that part is not confusing, okay? All right, let's go to number 4. Number 4 is saying, check if any car has a mileage greater than 50, okay? So it's saying check if any car. So what do we do if the mileage, if there is a car, a mileage greater than 50? It didn't say specific, so you have to kind of use common sense. In this case, we're just going to print it out, okay? So this one is going to be simple. Check if any car has a mileage greater than 50. So we look at the data structure. So let's actually make this so it's easier to see. We don't have to scroll up and down too much. When we look at the data structure, there is mileage. So we're just going to see if any mileage is greater than 50,000, and we're just going to print that car. So we're going to say, this one is going to be easy, right? We're going to say for I, let's do that. For I in cars, we're going to say if I mileage greater than 50,000, we're going to print something. We can print I for now, right? So what do we expect? Let's see. We have the Nissan is over 50. This one mileage is 5,000. It's not. This one is not. This one is 30,000. It's not. This one is 45,000. It's not. So none of them except for one is more than 50,000. So it's only the Nissan. So we should see when we run this file, we should see the Nissan being printed. So we're going to run that. So it says, oh, mileage. So I have a typo. So this error, right? Key error. I have a dictionary. I'm trying to access a key and it's saying I have a type. It doesn't find it. So mileage. I think this is actually misspelled, right? But I'm just going to keep it because it doesn't really matter. So let's run that. And now it printed the Nissan. That's really what we want. So we can make the printing nicer. So we can just say if we're going to say car with over 50k miles. We're going to say the make, or we can just print the make and model. So we can say I make, and say I model. Let's run that. Car with over 50 km miles is going to be Nissan Altima. Okay, if there were more, just to play with it, let's just change it. Let's say the Chevrolet is 60. Let's make it 55,000. Okay, so now if I run this, now it's going to print both of them. It's going to print the Chevy and the Nissan because they both are over 55. Another thing you really have to be careful is the question said over 50,000, right? Greater than 50,000. So we're going to do greater. If the question say greater than or equal to 50,000, we would have to do greater than or equal to. Usually when you're programming, that's called an edge case. It's like at the edge. Do they want to include 50,000 or do they not want to include 50,000? So you'd have to pay attention to the requirement, okay? All right, so we did 4 exercises. Let's go to another video and let's do some more. So we got 5 more to do here. We're going to do that in a different video. Let's keep going.